So the section 5 is intended for advanced level programmers to build an occur adaptation of the famous dining philosopher's concurrency problem. In computer science, the dining philosopher's problem is an example problem which is often used in concurrent algorithm design to illustrate synchronization issues and techniques for resolving them. Now I will quickly describe what is dining philosopher's problem, and then we will jump into the nitty-gritties of designing the solution. So as you can see here, this picture showcases 5 silent philosophers who sit at a round table with balls of spaghetti. There are forks placed between each pair of adjacent philosophers. Each philosopher must alternatively think and eat. However, a philosopher can only eat spaghetti when they have both left and right forks. Now as you can see, there are 5 forks and 5 philosophers. So each fork can be held by only one philosopher, and so a philosopher can use the fork only if it is not being used by another philosopher. So there is a problem of contingency here, as not all philosophers can have all the forks to eat spaghetti. So each philosopher can take the fork on their right or the one on their left as they become available, but cannot start eating before getting both the forks. So this problem is a classic example, usually to illustrate various challenges with concurrency. Now we will approach this problem incrementally, designing the actors which will model the problem and its solution in actor system. Through this example, we will explore the avoidance of deadlock and starvation in the design of actor-based system. Now, with this first video, we will start modeling each philosopher as an actor. So, as you can see, I've already created a new project. You can see the basic steps in our previous sections. I've configured the build.sbt to have a character library. Now let's start adding the actors for our system. Now each philosopher has certain properties. So as per the problem description, I'm trying to add those properties. So we have a name for the philosopher. We have left fork. Now here I'm taking advantage of actor system and I'm trying to define each fork as actor. So I'll keep left actor as actor F. Again, right as actor F. It should be an actor really. And we will be adding the implementation for receive method in further videos. Now that's the class for philosopher, and since we will be making each of the fork as actor, I'll create another class. Now we have defined a philosopher, which is an awesome dude or dudette who either thinks about eating or has to eat. So now there are two kind of behaviors here: philosopher who thinks to eat or who is eating. So in further videos we will start modeling philosopher's behavior as method inside our philosopher actor class. Now that's it with this video. We looked at the description of the dining philosopher's problem, and we modeled each philosopher from the problem as actor as well as the fork as an actor.